Okay, for those of you who've taken quiz 1A, which should be everyone by now, then you were not able to see which questions you missed or how you missed them, if you missed any. So I put together like our little quiz so that we could take a look at see how we did. All right. I skipped question 1 because we got 100% of us got question 1 correct. So I'm just going to question 2. For the number given, select all the number sets to which the number belongs. So 2/3. So I'm not necessarily going to go over the answers specifically to all of these exactly, but an irrational number, is a decimal number that goes on forever without repeating. So when I say without repeating, I mean like pi is 3.1415926, and there's no repeating pattern. A rational number can be written as a fraction. Can be written as a fraction. Any number we can write as a fraction is a rational number. Now, some numbers, it's difficult to tell if you can write them as a fraction. So if I give you a decimal like this, 0.571428, and if this pattern repeats, some of the patterns are difficult to tell if they repeat. This one does. This is actually, I think, 1/7, or no, 0.57. That would be like 4/7. And it's a fraction, so that's rational. Now, irrational numbers, anytime you have a square root of a number that is not a perfect square, so like the square root of 5 is irrational. But if you have a square root of a number that is a perfect square, then that's rational. So like the square root of 9. Or the square root of 6.25. Because if you square root 6.25, you get 2.5. Okay? So you have to sometimes do a little bit of math to be able to tell if it's rational or irrational. Rational numbers can be written as a fraction. Irrational numbers are decimal numbers that go on forever without repeating. So that should help you with question 2, 3, 4, and 5, and 6. Okay. So you'll have to let me know, send me a message if you still have questions about those. Some of the other ones. Some of these you just have to study like the properties a little bit. And some of the other ones were just like calculations. So on 7, which property of real numbers is demonstrated? -7 times 0 is 0. Anytime you multiply by 0, you get 0. That would be a 0 property of multiplication. Yeah, I shouldn't put an X there. Let's shade it in. Number 8. If you multiply 2/3 times 3/2, you multiply straight across. That's 6/6, which is 1. So basically, they canceled each other out. Multiplying by 3/2 canceled out to 2/3. So that's the inverse, multiplicative inverse. Anytime you multiply by 1, number 9, you get the same number back. See, 1 times 87 is 87, right? So 1 times x is x. It keeps the same identity. Multiplied by 1 does not change the identity. That's the identity for multiplication. Take a look at number 10. 59% of us got this correct. That's not very good. This is all addition and subtraction. Most people erroneously think that you add before you subtract, which is not true. Another way you could do the same problem is 10 plus negative 4 plus 3 plus negative 1. So do it that way. So you should go from left to right, or you should change everything to addition and then add them all together. But this one isn't about getting the correct answer. It's about determine the first step in evaluating the expression. Well, it's all addition and subtraction, so we're going to go from left to right. So 10 minus 4. Right there, subtract 10 minus 4. Oh, now if you put this, that's only true if we change it all to addition. But the way it's originally written is not all addition. Sorry. So you can't just do it in any order. 11, 12, we got 100% correct. 100% of us, we're not going to discuss those. So you can go back and take a look at those if you want to. 13, evaluating this. This is typically a difficult problem because of the negative signs and the multiplication and the exponent. So you have 5 times negative 1 squared, and then there's a minus sign, and then there's a 3 times negative 1 minus 5. So order of operations, you have to do the exponent first. So negative 1 squared. Negative 1 squared is negative 1 times negative 1, which is positive 1. So this is 5 times 1, which is 5. Now, this minus sign can be written as plus and a negative. So that's going to be plus negative 3 times negative 1 is a negative times a negative. So that's positive 3 plus 3 minus 5. This 5 and this minus 5, they cancel each other out, really. So it's just 3. It's 3. Evaluating this expression when x is negative 2 and y is 8. So same thing. 4 times negative 2 minus 5 times 8. Oh, I see the problem. There's a division problem there. 5 times 8 divided by 2. So you can't do this problem from left to right because we have division here. We know we have to multiply here. In this multiplication division, we're going to go from left to right. I'm going to go ahead and multiply these because it's separated by that subtraction sign from the other multiplication division problem. So I have negative 8 minus the answer to all of this multiplication division over here. So that's 40 divided by 2, which is 20, and that's negative 28. Okay, simplifying, the first step in simplifying, you cannot do 5 minus 2. That's not it. You have to distribute the negative 2. Now there's 2 of those options here, distribute negative 2, but the simplified expression is different. So if we distribute the negative 2, I'm going to do that by making this plus negative 2. So that's going to be 5 plus negative 2 times 4x is negative 4x. And negative 2, that's also a negative 5. Negative 2 times negative 5 is positive 10. So that's a positive 5, and that's a positive 10. So that's going to be a positive 15. Oh, that I wrote negative 4x. That's negative 8x. So that's negative 8x plus 15. Okay. Let's see, 16, almost everybody got that one right. You can only combine the like terms. 7x minus 9x, that's negative 2x. Plus 5y, plus 3y, that's plus 8y. And then plus 15. Okay, 17, almost all correct. 3 times the difference. Difference is subtraction. We're subtracting 8 and a number, so 8 minus the number. 3 times that difference would be like that. You have to use parentheses. because the difference is the answer to the subtraction problem. Look at this one, 59% correct. That's not very good. 15 less than the product. No, 15 less than something is where you subtract 15 from something. We're subtracting it from the product of 5 and a number, so that would be 5 and minus 15. 19, the translation, twice the sum of A and B, almost all correct. The sum of A and B has to be in parentheses because that's the answer to the addition problem. A plus B, twice the sum is 2 times that. Okay? Not to the second power, multiplied by 2. Okay, if I'm twice as old as you, then I'd take your age times 2. Don't take your age and square it. Yeah. Don't do that. The prime factorization of 60 and 48 is given what is the greatest common factor. Okay, if you want to use the prime factorization method to find the greatest common factor, which is what I was hoping you would do here, which you didn't have to do, but that's what I was hoping you would do. You're looking for the common factors. It's the greatest common factor. The common factors. See, those 2's are in common there. Those 2's are in common. The 3's are in common. Those are all the common factors. So I believe it's going to be 2 times 2 times 3. Okay. Prime factorization of 60 and 48 is given, again, the least common multiple. Okay, so we're looking for something that is a multiple. And to be a multiple, it has to be at least as big as the smallest number. So that means at least you have to have all of these 2's. You have to have all of those. Okay. And you have to have all those 3's. But it also has to be a multiple of 60, which means you need all of the 5's. So it should be 2 times 2 times 2 times 2 times 3 times 5. Question 22. 6% of us got this correct. That's a commonly missed problem. Which steps could be correct to do first? Choose all that apply. Maybe the reason that only 6% of us got this correct is because 6% got the whole thing correct every single choice. Okay, so maybe you got 1 or 2 out of 3 or 3 out of 4. I haven't read it yet, so I don't know. So what could we do? Subtract 1/2 from both sides. That would be okay. We could do that if you want to. That's allowed. See? You could just, minus 1/2. Minus 1/2. Yeah, that's allowed. How about getting a common denominator for all terms on both sides? Yes, we could do that. That's what I would do. So we would make them all 6. So this would be 4, 6x plus 3, 6 equals negative 5, 6. Yeah, and then cross out all the denominators. So that's allowed. Multiply both sides by 6. Yes. If you multiply both sides by 6, this whole side and this whole side multiplied by 6, the result is the same as getting a common denominator and canceling out all the 6's. See, 6 times 2/3 x is 4x. 6 times 1/2 is 3. 6 times negative 5, 6 is negative 5. And see, that is the equation that we would be solving if we got a common denominator and we crossed out all the denominators. So we can do that. Combine 2/3 and 1/2? No. Because the 2/3 is a x term and the 1/2 is not. Those are not like terms. 23, all we had to do is solve this equation. There was no choices for a first step or anything, so you had to subtract 13 from both sides. Don't forget about your negative 2x. 29 minus 13 is 16, I believe. And then divide by negative 2. Solving this equation, if you distribute the 2 here, we're on number 24, that would be 6 6x plus 10, 18 minus 2x. Now we have x's on both sides, so I'm going to add 2x to both sides. I'm also going to subtract 10 from both sides. So I can cancel out those and have 8x. 18 minus 10 is 8. And then divide by 8. Okay. Ooh, 25. 47% of us got this correct. Solve the equation. See, I'm guessing a lot of you just mentally solve the equation without writing down the work. 2x minus 3 equals 3 minus 2x. See, those 2x's and 3's don't cancel out. If you cancel out this minus 2x by adding 2x, then these cancel out because you have a minus 2x and a plus 2x. And now you have 4x over here. If you add 3 to both sides, then this negative 3 and this positive 3 cancel out, but these 3's don't cancel out. 3 plus 3 is 6. So if you divide by 4, 6 divided by 4 is 1 and 2/4, 1.5. Solve the equation 2/3. Did I make a mistake on that one? 6. Oh, see, I probably did that upside down and I wrote 6/4. So I'm going to go back and I'll give everybody credit for number 25 because it should be 1.5, not 2/3. No wonder only 47% of you got that incorrect. Correct. So my apologies on that one. So I probably did the same thing you did. I did it on my head, and then I didn't write it down, and I just got 2/3 instead of 3/2. See, it should be 3/2. Oh well, live and learn. 26. Write your own equation using x as a variable where the solution would be all real numbers. Okay, now to be all real numbers. Some of you actually, I know you wrote this equation because you thought that answer was all real numbers, but that answer is not all real numbers. I won't be able to give you credit for number 25 if you wrote all real numbers on that one. I'll just take it out. 26, all real numbers, the left side and the right side have to be exactly the same. You know, you could have 2x plus 3 equals 2x plus 3. Some of you wrote some things that are way more complicated than that, but basically what has to happen is all the x's have to cancel out on both sides, and then whatever's left has to be equal like that. 27, we got almost all correct. Solving for A, if you put 12 in for B and 13 in for C, that would be A squared plus B squared, which is 12 squared equals 13 squared. You have to square those. A squared plus 144 equals 169, and then subtract 144 from both sides. Oops. Subtract 144. So a squared equals 25, and then square root. Solving the equation on number 28. Nothing special about that one, I believe. Let's solve it and find out. On the left side, we have distribute to 3, so that's 12 minus 6x. We have to distribute that negative 2, so that's negative 6x. Negative 2 times positive 7 is negative 14. Combining like terms over here, we have a 5 and a negative 14. So on the left side, we have 12 minus 6x. On the right side, we have negative 6x minus 9, I believe, because when I combine a positive 5 and a negative 14, I get negative 9. Now in this one, if I add 6x to both sides, they do cancel out. So that's 12 equals negative 9. And that would be no solution. Ha! Somebody did ask me about number 25. I remember that. Number 29. Only 65% of us got this one right. Let's see if I made a mistake on it. I'm going to get a common denominator, so I'm going to get a denominator of 6. I'm going to multiply this side by 3 over 3 for that fraction. I'm going to make this 1 into 6 over 6. And then I'm going to multiply this side by 2 over 2. So that's going to be 3 parentheses x plus 2 over 6 plus 6 over 6 equals 4x over 6. Distribute the 3 to make it 3x plus 6 plus this other 6 equals 4x. If I subtract 3x from both sides, then I should get 4x minus 3x is 1x. 6 plus 6 is 12, so x equals 12. Does come out to be 12. The last one, number 30. I did this one by not distributing the 3/5. I multiplied both sides by 5/3 because I didn't really want to distribute the 3/5. If you had watched the lesson on these equations with fractional coefficients, then you would have known that you could do this. I know it does take some practice. But now this 5/3 multiplied by 3/5 cancel each other out because it becomes 1. And I just have now 2x minus 7. 21 times 5/3. 3 goes in 27, or 21 7 times. So that's 35. And I can add 7. So 2x equals 42 and divide by 2. Nice whole number answer. So anyway, if you're reviewing and you want to check to see like which problems did you miss and what did you do wrong, I wanted to provide this for you so you could tell. So I hope that's helpful.